In this video, we're going to talk about descriptive statistics of a data set. This is the lowest level of data analysis that we really start to look at what has happened to a set of data in the past. Again, this is something that's happened in the past, and we're just trying to describe what has happened. It's one reason why we talk about it being descriptive statistics. In our case here, the very first set of data that we're looking at is the location or central tendency. What is the data, what's the central thing? And what we normally think about with data is an average. And for this one, we're going to look at this first part is the average spending for clothing. If I start to type in equals average, here the function comes up. I'm going to double left click for average. I'm looking only at clothing. And the average spending for clothing for these 130 customers is $168.68. Again, that is the average. Mathematically, that is the center point of what the 130 people spend. Sum all of the data up and then divide by 130 customers, and mathematically, again, that's the average. However, that's just one part of the central tendency because it just gives us one piece of what's going on. We also know that there is a center point called the median, where the median is where we have half of our values that are above this location and half of the values below the location. For our case, that's $149. There are 65, because there are 130 customers divided by 2, 65 who spent more than $149 on clothing, and 65 who spent less than $149 on clothing. But that's kind of, again, where we're kind of grouped in the center. We need to also know, how far apart is this data living? How does this work? So if I'm looking for minimum, I can type in equals min, double left click, and go and highlight the clothing spending. And we find that the lowest that we have is $11 that someone spent, and the max that anyone spent on clothing for these customers is $399. That means we've gone from a bottom of 11 all the way up to $399. The center point mathematically is $168.68, but the middle point where there's as many in the upper as there in the lower is $149. The range that we have in spending, you remember that is the max minus the min. So we have a range of $388 in spending between our lowest to our highest value. And then another part that's really kind of nice for us to be able to look at from a location or central tendency point is called the mode. The mode is what happens the most frequently in our data set. Excel allows you to calculate either a single mode or a multiple mode. I'll tell you from practice that multiple mode does not work inside of Excel because it can only return one value. So I'm going to double left click on single mode. And again, the mode is which value has occurred the most frequently. I know that you've used this before in math class, and when we finally get to forecasting, it's going to make sense to you why we really do calculate a mode. Mode 14 is what happens the most frequently. Next, percentiles. Percentile says, if I use the percentile inc, it says if I look at my data, what is the value for the, I'm going to say 25th percentile, 0.25. This tells me that there are 25% of our customers who spent less than $76.75, which means that there are 75% of our customers who spent more than this value. Let's do that again for 50th percentile. I'm going to double left click. We'll use the same array of data. type in 0.5. 0.5 is saying that we know that 50% are above $149 and 50% are below it. Remember, that is exactly what the median is, okay? The 50th percentile and the median tell you the exact same thing because mathematically they are the same answer. All right, I'm going to let you do 75th percentile on your own. However, I do want to show you that there is a shortcut on being able to do these descriptive statistics that sometimes you may find useful to you. If you go to the data and look over in your analyze, you should see data analysis as one of your options. If it's not there, you can go in and add the data analysis tool pack in Excel. It doesn't cost you anything, and there's a video for you to be able to do that. I'm going to left click on data analysis. This descriptive statistics is one of the options. I'm going to click OK. I want to select my clothing data, C1 through C131. All of my data is in columns. I have labels in my first row. Place this in a new worksheet for me and just give me the summary statistics for right now. I'm going to click OK, and here's our data. Again, 168.68 is what the mean is, which is exactly what we calculated with our average. Okay, that completes the first two steps of this exercise. Now I want to use the average if, because there are times when I want to start segmenting my data and pulling it apart and saying, is there any truth based on this data set that perhaps women buy more clothing than men do? So I can use an equals average if, and double left click, the range that I'm looking for. First of all, I want to separate based on female, so I'm going to highlight starting with a header. The criteria that I want to put in here is that it needs to be female. And the data that I want to analyze is clothing. All right. That says that 225.67 is what women on average spend according to this data set. Now, you can do the exact same thing for males in just 1 second. But let me show you that we can also use pivot tables to do this exact same thing. I'm going to come back over to our clothing data. I'm going to click on Insert Pivot Table. Make sure that the data is listed here, A1 through F131. Let's put that in a new worksheet. Click OK. I'm going to take gender and bring it to my rows. And then with clothing is what I'm looking at now. If I left click on clothing and drag it down to the values, what Excel does, it tries to first of all say, I think that you want me to sum up the clothing. No, that's not what I wanted. I really wanted the average. So if I left click on sum of clothing, value field settings allows me to go in and change this from a sum to a count, an average, a max, a min, or whatever else that goes in here. I'm going to click on average and click OK, and you will see that it will calculate for us using a pivot table. $225.67 is what it is for women, which is exactly what we did with our average if statement, and that men only spent $97.93. All right. So what we just finished was that you can see that by putting in a pivot table, you could calculate the average for female and male. You could also do the min and the max for male and female. And then once you have the min and the max, you could calculate the range, right? Because that's just the max minus the min. Once you've done that, we have a very good idea of our central tendency. We have those central mathematical points where our data is gathered. We call that the average. We use that a lot in business. However, we also use the median, or we should use the median a little bit more, because it tells us that 50% of our customers are spending more than the $149 or less than $149. All right, again, that's a central location. The next piece that we're going to talk about is dispersion. Dispersion tells me how spread apart are things. Standard deviation is one of our normal ways that we look at dispersion, because the standard deviation is the average distance that things are away from the center. Now we square that value and then we take the square root of it because of the issues with numbers being above the average and below the average. But let's just go ahead and put in ST DEV. This is for a sample, so we're going to use the .s. If you had the entire population of data, you would use .p. However, we're just using a sample, so stdev.s of our clothing. That gives us the standard deviation for clothing. Variance, we can do the exact same thing, variance.s. This is the squared value for a sample. And then finally, what was called the coefficient of variation. Coefficient of variation is how much wobbling, if you will, with variance, do we have compared to the average for our total. So the way we calculate that is the standard deviation divided by the average for clothing. This says that we have almost 66% wobble, if you will, or dispersion of our average is also based on the standard deviation there. So once again, you can do that for the other categories. And once you've done that, I need you to answer the question, which one has the greatest dispersion? Which means if the coefficient of variation is higher, it means that we have more variance or wobble in our data compared to the average. It's just a way to take and compare all of the different values. All right, next thing is association. I know correlation is one of the things that people use the term often, but there is a mathematical calculation for a correlation, and it tells us that items can be correlated from -1 all the way up to +1. And correlation is really how much variance in one variable can we explain by another variable. So in particular, I'm going to take the very first one where I'm looking at the correlation between clothing and health. We can take and calculate that by using the CORREL function. And in it, it wants two different arrays. It wants the array for clothing okay, and then it wants the array for health. This says that there is 0.03 is the correlation. So there is a very small, all right, because correlations we'll talk about later on about the strength. This is a positive correlation of just 0.03. Now you can do that for each of these relationships, or let me also show you that when we're in here, we can go back to data analysis, and one of the other options that we can do is correlation, and we can click OK. We can select all four of these categories. All right? Tell it's in a column. Labels are in the first row. and that we wanted to put it into a new worksheet. I'm going to click OK, and you'll see that we calculated the clothing and health a few minutes ago, but Excel has gone through now and calculated all of your correlations for you. So you could just take this information and bring it into the dispersion, calculate the, sorry, you don't need to calculate anything there. You just need to select which of the two variables are most closely related, all right? Please remember that you're talking about magnitude here. Items can have a negative correlation or a positive correlation, and the strength really is the total value, in this case, 0.03. All right, last thing that we're going to look at here is outliers, because there are times inside of our data set that we need to determine, do we have any outliers that are in our data, because we may need to remove them from our data set. We'll talk about this in an upcoming class or video when we're talking about statistics, but the z-score is the number of standard deviations that an item is away from the mean. So a z-score of -3, to calculate that, that is the average. We're going to use clothing here. So we're using the average for clothing. And in this case, we want to subtract 3 times the standard deviation. All right. So the z-score for this case would be, we would have to have less than $165 worth of spending. Mathematically, that's impossible because no one can go below 0. So an outlier that's on the low end of our average doesn't make any sense. However, we can also do the z-score, which is the average plus 3 times the standard deviation, and to determine that the z-score for this is $502. All right, with that, 502 is the maximum, right? If anything, if we had any data point that was above 502, then we would be able to say that there was an outlier. We know from our data that the maximum that we have is 399. However, we could go in here and add a column and mathematically go down through and look at the values. As a matter of fact, what I just did was for the only for the clothing, and instead we should have been doing that for miscellaneous. So I need you to, now that you know how to calculate your z-scores, calculate this for miscellaneous and determine if you have any outliers. All right? You can do that by putting in a column here called miscellaneous outliers and just label any values that would be either below the -3 or above the +3 standard deviations from the average. I hope this makes sense to you. Good luck. Let me know if you have any questions.